Math 3, Unit 8, Section 3. So today we're talking about standard deviation, okay? Standard deviation is the average difference from the mean and measures how spread apart a set of data is. So basically the idea kind of with standard deviation is seeing like what is the distance between numbers. It's kind of taking an average to see what's going on, okay? How you calculate the standard deviation. The first thing you do is you calculate the mean or average of the data set. And remember, we talked about this yesterday. Okay, that means mean. We find that by, remember this, what does this letter mean? Sum of all numbers, and you're dividing it by the value n. That's how we find the average. Then you're going to calculate the difference between each value and the mean. And I'm going to show you what we're going to do here in just a minute. Once you do that, you square those numbers, and then you take the average again. That number is called your variance. This right here is the symbol for variance. And you take the square root of that value, and it gives you the standard deviation. This is the symbol for standard deviation. Okay, does anybody know what this Greek symbol is called?
E.
I believe it's sigma. Okay, phew. Okay. All right, here we go. So first example, and this will all make more sense once we do this. It says, find the mean, variance, and standard deviation to the nearest tenth for the weight in pounds of fish caught. Okay, here is our data set, all of these numbers, okay? So, do you see here X? We're going to go ahead and just write those numbers here. 5, 6, 30, 43, 9, 27. Okay, what does that mean? The mean or average. Okay, so we need to find the mean of this set of data. How do we do that? Add them all together. So, 5 plus 6 plus 30 plus 43 plus 9 plus 27 equals 120. Divided by, how many pieces of data do we have?
6.
And 120 divided by 6 is 20. So right here for the mean, we're going to write 20 in all of them. Okay, this is where we're going to subtract the two numbers. Now you could rewrite 5 minus 20, but that just does not sound like something I want to do. And so all I'm going to do is in my calculator, to help myself out, I'm going to go 5 minus 20, which makes negative 15. And then I would keep that number in my calculator because we're going to end up squaring all these numbers. And so you can just press to square your answer, and it's 225. So in this next column is going to be 225. And we're going to do that for each of the numbers. Do I need to make this larger for some of you? Yes? Okay. Is that better? Okay, so we're going to do it again. I'm going to go 6 minus 20, which is negative 14. And then we square negative 14 and get 196. Okay, so next we have 30 minus 20, which would be 10. And 10 squared is 100. 43 minus 20 is 23, and then squared makes 500. Did I write a number down wrong? Okay, 529. 9 minus 20 is negative 11, and negative 11 squared is 121, good. And then 27 minus 20 is, and then 7 squared is 49. If you go back to the instructions, we calculated our mean. Okay, that was done. The difference between the numbers, we did that. Square each of the numbers, we do that. The last step in order to calculate the variance is you have to take the average mean of each of these numbers. So now we are going to take the mean of this. So we're going to add all these up together. So getting our calculator out, we have 225 plus 196 plus 100 plus 529 plus 121 plus 49, which equals 1,220. So I'm just going to put that I added all those up, and then divides by, how many numbers do I have there? 6. And so it's said to the nearest tenth. And so for my variance, which is sigma squared, that is 203.3. So you look here at this number, we round to the nearest tenth, 203.3. Now, our standard deviation, and if you want to write this here so you remember, that is called the variance. And then the next one is standard deviation. And my standard deviation is taking the square root of 203.3. Now, to make my answer more accurate, do you see how I have this number in my calculator? I just leave it, and then I end up taking the square root of my answer. So depending on your calculator, you might just be able to press the square root button. For me, I have to do square root and then put in the answer key, and then I press enter. And rounding to the nearest tenth, what do I get? 14.3. And then again, I want you to write, make sure you write your symbols so that you get used to knowing that standard deviation is this symbol, variance is this symbol. So it asks you to calculate the mean. So up here we had our mean was 20. Our variance is 203.3. And the standard deviation is 14.3. Okay? All right. We're going to do another example. Okay? So the next example is we are going to find the same information for fish again, but if you notice that here, the data for the fish, they're different weights. Okay, so we're going to see what happens when you have different weights. Okay, so we're going to write our numbers again for x's. We have our 24, 19, 15, 23, 18, and 21. For some reason, we have an extra row there. We need to find our mean. How do we find our mean? Add them all up together. So we'll get out our calculator here. So we have 24 plus 19 plus 15 plus 23 plus 18 plus 21, which is 120. And how many pieces of data do we have? 6. 120 divided by 6 equals 20. So this mean and our previous mean are the same. So I wonder what's going to happen with the variance and the standard deviation, if those might be similar. Okay, so we're going to put our mean for all these numbers. Okay, next we subtract them and then square them. So 24 minus 20 is 4, and 4 squared is 16. 19 minus 20 is -1, and -1 squared is 1. 15 minus 20 is -5. -5 squared is 25. 23 minus 20 is 3. 3 squared is 9. 18 minus 20 is -2. -2 squared is 4. 21 minus 20 is 1, and 1 squared is 1. Okay, who remembers what our next step is? Very good. We're going to take all those, add them all up together. So we'll get our calculator here again. 16 plus 1 plus 25 plus 9 plus 4 plus 1 equals 56. And we're going to take that and do what with it? Good. Divide that by 6. And when I do that, we get 9.3. Okay, so what number does this represent? Our variance. Very good. So variance, which is our sigma squared, is 9.3. So our standard deviation, I'm going to abbreviate that as SD. What do we do in order to find that? Very good. Square root of 9.3. So in your calculator, we could just leave what our answer is. That's already in there, and just take the square root of the number that's there. And if we round that to the nearest tenth, that will be what? 3.1. So if we look at these two examples, I might have to make this a little smaller here. What was the smallest number here? 5. And the largest number was 43. What was the smallest number here? 18. And the largest number was 24. Standard deviation is kind of, yes. Oh, thank you. Standard deviation is kind of talking about the spread of numbers, like how many numbers are in between each number. They're kind of taking the average there. So here it's saying that between each number is about 14. Here, between each number is about 3. So on this problem, even though the mean is the same, the numbers are a lot more spread out. Where here, even though the mean is the same, all the data is close together. So the standard deviation is telling you, like, if you were to think about this in terms of like a dot plot, these dots would be way spread out, where these dots would be much closer together. Does that kind of make sense? All right, we're going to go ahead and turn the page. So we're going to go ahead and find the mean and standard deviation, but you have a much smaller set of numbers. We'll do this one together. So how do I find the mean? Add them all up. So again, our mean is adding up all the data. So 3 plus 5 plus 10 plus 12. We add that together, and what do we get? 30. And there are 4 pieces of data there, so we divide by 4, and that makes it 7.5. When you're finding your variance and standard deviation, I think the best thing is to set it up how we set up our other problems. So that is where we write each of our piece of data. So we have 3, 5, 10, 12. And then you're always going to subtract the mean. So I'm just going to write minus 7.5, minus 7.5, minus 7.5, minus 7.5. You can make it a chart if you want to. It's kind of up to you on how you do this. So because I'm dealing with 0.5, I'm going to go ahead and get out my calculator. 3 minus 7.5 equals negative 4.5. And then we square that number, which is 20.25. So it's nice if you just keep these numbers in your calculator, because you can do these things pretty fast. Okay, so next we have 5 minus 7.5, which is negative 2.5. And we square that and get 6.25. 10 minus 7.5 is 2.5, and we square that and we'll get another 6.25. 12 minus 7.5 is 4.5, and we square it and get 20.25. Okay, who remembers the next step? Very good. We have to add all these up together. Okay, so 20.25, oops, plus 6.25 plus 6.25 plus 20.25 equals 53. And what do I do with 53? Good, divide it by 4 because I still have 4 pieces of data. So I still have that number in my calculator. I divide it by 4 and I get 13.25. So for these answers, unless they said to the nearest 10th, once you get to this point, I want you to write it out at least 3 decimal places. But like your data within your graph here, just do 1 decimal place. Okay? So that's 13.25. This number is my variance. And then in order to find the standard deviation, what do? Very good. We take the square root of 13.25. And so in my calculator, I'm just taking the square root of my answer, oops, which is, we're going to take this one out to 3 decimal places. 3.640 is my standard deviation. Okay, any questions? Colton, put it away, please. Okay, on B, it says now increase each number by 2 and recalculate the mean and standard deviation. We want to see that if I take every number in my data set and add 2 to it, what's going to change? How's my mean going to change and how's my standard deviation going to change? Okay, so my new data set, I'm just going to write them down here. Adding 2 to each number will make my data set what? 5, because we go 3 plus 2 makes 5. Good. And then 5 plus 2 is 7. And then 10 plus 2 is 12. And then 12 plus 2 is 14. So now when we take that average, we add those up together. And what do you get? Good. And 38 divided by 4 is what? 9.5. Now right now I want you to look. This mean was 7.5. This means 9.5. What happened? The mean increased by 2. So if you had a data set and you found that the mean was 7.5, and then somebody's like, oh no, I messed up. Everybody had 10 more points than what I originally had said in that data. Would you have to recalculate the mean? No. If everything in that original data set increased by a specific number, then all you have to do is increase your mean by the same specific number. You don't have to do all the calculation again. So let's see what happens with the variance and the standard deviation. Okay. So I'm writing down each of my numbers again. So we have 5, 7, 12, 14. And then what do I do with that information? Good. Subtract the mean. So subtract 9.5 to each of those terms or numbers. So I just write minus 9.5. Again, if you want to make this into a chart so it's more organized, hopefully you can write straighter lines than me if you want that. Okay, so 5 minus 9.5 is negative 4.5, and when you square it, it makes 20.25. 7 minus 9.5 is negative 2.5, and when you square that, it makes 6.25. 12 minus 9.5 is 2.5, we square that, it makes 6.25. 14 minus 9.5 is 4.5. We square it and it makes 20.25. Okay, we already know this is the same data. If you look here, same data as this problem. So when I add all that up, it makes 53. 53 divided by 4. Very good, 13.25. So that means that for my variance, it is 13.25. My standard deviation is going to be what? 3.640. Okay, so thus, let's look right here. If you have a set of numbers and each number is increased by the same amount, the mean, what happens to the mean? Very good. Increases by the same amount. And the standard deviation, what? Stays the same. Very good. And if you think about that, the standard deviation is talking about the distance between numbers. Can you guys read this or no? We're good? Back there? The standard deviation is talking about the distance between numbers. So if you're adding 2 to everything, the distance between the numbers is going to stay the same because everything's just shifting by 2. Does that kind of make sense? Okay. Now, C says, now I want you to multiply each number by 2 and recalculate the mean and standard deviation. And how does this affect it? Okay, so going back to our original set of data, the first number was 3. When I multiply 3 by 2, what does it make? 6. 5 times 2 makes 10. 10 times 2 is 20. 20 times 2 is, 12 times 2 is 24. Okay, so we're going to get our mean here. We add all those up together, and what does that equal? 60. We divide that by 4, and we get 15. Now, looking at 15 and going back to our mean of 7.5, how are they similar? You can't really see them together here. Very good. So you know how I multiplied each of these numbers by 2? If you multiply 7.5 times 2, guess what it makes? 15. So again, we wouldn't have to do all that stuff. If we're multiplying all of them, all it's doing is, how does it change this? Multiplied by 2. Okay, so we're going to write down our data. 6, 10, 20, 24. We're going to subtract the mean, which is 15. So we have minus 15 on all of these. 6 minus 15. Negative 9. We square that and it makes 81. 10 minus 15. Negative 5. Square it. 25. 20 minus 15 is 5. Square it. It's 25. And 24 minus 15 is 9. We square it and we get, yes. Why do we multiply by what? So we're just seeing how it's changing. So we're comparing, like we're taking our first set of numbers and seeing what happens when you compare the first set if we add everything by 2. How did it change? So what we found was that the mean increased by 2, but the standard deviation and variance stayed the same. I'm sorry that I just can't hear all this. Sorry. Okay, say that again. Yeah, so we just want to compare. We're just seeing like, okay, now what happens if we use our original set of data and we multiply it by 2 versus adding by 2. Okay, so now we're going to add these up so we can find our variance. And so when we add all of them up together, what did you guys get? Good. 212. And what do we do with 212? Divide it by 4. And what did that equal? 53. So my variance is 53. What is my standard deviation? Very good. 7.280. Okay. So if we go back and we're just looking at our standard deviation, how do those compare? This one also multiplied by 2. If you take 3.640 and you multiply it by 2, you get that number. Okay? So, thus, if you have a set of numbers and each number is multiplied by the same amount, the mean is multiplied by that amount. And the standard deviation also is multiplied by that amount. So when you're multiplying by a number, both the mean and the standard deviation will change. But when you're adding and you're just kind of shifting things, only the mean changes, but the standard deviation stays the same. Okay? Now, this is kind of a thinking question. Okay? What is the standard deviation of a class if everyone in the class scored an 85% on the exam? What do you think? So if in our class, every single person on here scored an 85. Remember, standard deviation is talking about kind of the spread of numbers. What is the distance between each number? What is the distance between each 85? 0. Okay? And so this answer is 0. And if you think about it, I'm going to put because. What would, if we were to add everybody's scores up together and we added 85 38 times and then divided that by 38, we would get 85. Agreed? Our mean would be 85. And remember how you subtract your data and your mean? What's 85 minus 85? 0. And if you square 0, you get 0. So I'm going to put because the difference between the mean and each score, I can't spell, would be 0. Okay, any questions?